Hey guys, welcome to another video. Now, we are continuing on with our topic of simultaneous equations, and we're going to be looking at another method for solving these in this video, and that is the idea of elimination. Now, in the previous video, we looked at this idea of substitution, so finding a way to substitute our variables in a bunch of different ways, hence the name. Now, what we are going to be doing today is doing some operations with these two equations and moving some things around, changing our equations, doing these operations in order to actually eliminate some of these variables instead of substituting them. Now, that's going to involve a couple of slightly tricky procedures, but we're going to cover those very thoroughly in this video using two particular examples. Now, I've got one pair of simultaneous equations here, and as we said in the previous video, all of these ones are especially these variables, x and y, they are the same in each equation. So this x is the same as this x, this top y is the same as the bottom y. And what we're going to do is we're going to look at making what we call equivalent equations. So we're trying to make some change to one of these equations to get my variables and the coefficients, so these numbers in front, to be the same, so that when we add or subtract one equation from the other, our variable is going to get killed off. Now, taking a look at equation 1, this is y minus 3x equals to 1. And now, this y, it's implied that there is a 1 in front of that. Anytime we have just the pronumeral, we assume there's a 1 in front of it. Now, have a think, is there a way that we can get this 1 to a 2 via some type of multiplication? You can probably see here that if we were to multiply 1 by 2, we would get to 2y. Or multiplying 1y by 2 will give me 2y. And with our equations, what we do to one particular element, so we can't just multiply something by the y and then we get the same thing. No, we need to, what we do essentially to one particular thing, so to this 1y, we're multiplying it by 2, to give us an equivalent equation, we want to do the same to the remaining two terms. So what we're essentially doing is we're taking our entire equation 1 and multiplying it by 2. So every single element here is going to change. So my 1y is going to become 2y. My negative 3x, multiplying that by 2, is going to give me negative 6x. And my 1, I'm going to multiply that by 2 to give me 2. So this is equation 1 rewritten in a different way. So let's just call that 3 for now. Equation 3. So now that we have the equal coefficients here, I have a 2 here and a 2 here, I can now subtract one equation from the other. And that's going to just kill off these completely. Now let's look at how that will look mathematically. Here we're going to take, for example, equation 2. And we're going to subtract equation 3 from it. Or equation 1 just written in a different way. Now, when I do that, 2y minus 2y, that gives me 0. 5x minus 6x, because remember here we have to be careful with our signs. We're subtracting 3 from 2. So I have positive 5x and I'm subtracting negative x from that. So that will give me 5x plus 6x, which gives me 11x. And I have 13 minus 2, that gives me 11. Now I have 0 plus 11x, so I can just write that as 11x equals to 11. And now it's just a matter of solving this equation. I can do this by dividing both sides by 11, doing the opposite operation to this multiplication here, and I get a value of x equals to 1. So I've found, in the same way as substitution, by eliminating one of the variables, I got a new equation with just one particular unknown pronumeral or variable, whatever you want to call it, to actually end up solving for. And now that I have this value of x equals to 1, like with the end bits of the substitution method, I just need to put this value of x into one of these equations in order to find my y. Now, like we said in the previous video, we want to go with the path of least resistance. So we want to put this in the equation that is going to be the simplest to work from. And that one is going to be, I don't know about you guys, but to me, it's going to be a lot easier to sub in the x here, because it's just y minus 3 times whatever that is equals to 1. It's a far easier thing to substitute into. So what I'm going to do, I'm going to sub x equals 1 into equation 1. So I get y minus 3 times 1 equals to 1. And 3 times 1 just gives me 3. So this is saying y minus 3 equals to 1. And now it's just a matter of solving this equation. So I'm subtracting 3 from y, so I'm going to add 3 to give us y on its own. And I get a value of y equals to 1 plus 3 gives me 4. So my elimination method, like the substitution method, it's just making some changes to my equations so that I can get left with one particular variable. The only way we can solve this is to use the equations, manipulate them, give us a way to just solve for one variable, like we did with this x here. Okay, let's try another example. Oh, actually, if I scroll down, we have my second example here. Now, this one is slightly harder because in the previous example, we could get 1y to 2y quite easily. But here, it's not immediately obvious how we can make any of these variables the same. But if we look, we want to see if we can make some changes to our equations 1 and 2 here. So I can see there's not one, I can't make, for example, 3 into 5 very easily, nor can I make 2 into 3. But I can find the lowest number factor, the lowest number in which 2 and 3 is a factor. So, for example, I'm just going to work with the y's here again. I'm going to get these two by changing these via multiplication. I'm going to try to change these to get me to the same coefficient. So, what's the lowest number that 2 and 3 go into? Well, both of them can go into 6. That's going to be the smallest possible number. So, to get 2y to 6, I want to multiply it by 3, and to get 3y to 6, I have to multiply it by 2. And so that when we end up subtracting, we can kill off one of the variables. We can eliminate this variable. So, as we said before, I can't just change 2y to something else by timesing by 3. I have to do it to every single part of this equation. That's the only way I can make an equivalent equation. So, what I'm going to do is I'm going to take equation 1 and multiply it by 3. And I'm going to take equation 2 and multiply it by 2. I'm going to do these two operations all at once. So, timesing equation 1 by 3, each of my elements are getting multiplied by 3. So 3x times 3 is going to give me 9x. And I'm going to get 6y here. 2y times 3 gives me 6. And 6 times 3 gives me 18. And I'm going to call this equation 3 now. And I'm doing a similar thing to equation 2. I'm just multiplying it by a different number. So I'm going to multiply once again each element here by 2. Okay, so 5x times 2, that's going to give me 10x. I'm going to get 6y here. And I have 11 times 2, that gives me 22. And I'm going to call this equation 4. All right, now, if I subtract one from the other, my variables here of 6y, 6y, they're going to get eliminated once I do this subtraction. So I'm going to take, for example, equation 4, and I'm going to subtract equation 3 from it to just leave me with my x's. So I have to do this operation between each of these elements in my equation. So I'm subtracting 9x from 10x, that just gives me 1x, or just x, plus 0, because 6y minus 6y gives me 0, equals to 4. And this is relatively simple because there's a 0 here that just means nothing. I have x on its own equals to 4. That is my x solution to this equation. And now we just want to substitute this back into one of my 2 equations at the start. So I can just substitute it into 1. So what we're going to do is we are going to sub x equals 4 into equation 1. So I'm going to get 3x, or 3 times 4, plus 2y equals to 6. Let's see if I've just done that correctly. Perfect. So 3 times 4, that gives me 12, plus 2y equals 6. And now I just want to systematically solve this equation. So this is nothing new. We've done this stuff before. I want to subtract 12 from both sides. That gives me 2y on its own equals to 6 minus 12, gives me negative 6. And then I just want to divide both sides by 2. And I will get y equals negative 6 divided by 2 gives me negative 3. So elimination is all about making changes to these equations via scaling them up or down. So by multiplying them by some kind of factor. Whoops. And how we decide to do this doesn't really matter. You could have chosen to eliminate the x variables first. You could have found that the lowest number that 5 and 3 go into, or 5x and 3x go into, is 15x. So you could have times the top equation by 5, the bottom by 3, and then just done the same elimination to just get you with your y's, to get you just your y's remaining. But no matter which way you do it, when you do this elimination by subtracting the 2 equations, you will get the same solutions no matter which way you go about it. So elimination is all about, firstly, changing our equations via some kind of multiplication, and then performing operations between those equations. So subtracting one from the other to just give us an equation with only one variable to solve for. But that is the second method for solving simultaneous equations. This is how we can do these using elimination. Thank you so much for joining me, and I'll see you in the next one.